Okay, so as promised, we are going to, in this video, take what we know about classifying the sides of a right angled triangle, as well as starting to understand the the trigonometric ratios and working with those. And we are going to mesh those together and apply them to a question, to a real world question. So here I have attached a question that says a string of a kite is 100 meters long and the inclination of the string with the ground is 60 degrees. Find the height of the kite, assuming there is no slack in the string. So let's decompose this question and take the most important bits. So I have a string of a kite which is 100 meters long, and the inclination of the string with the ground is 60 degrees. Now, we want to find the height of the kite from the ground. So, in approaching these worded questions, especially in trigonometry, the best thing I can advise is to draw a picture first. So, say I'm flying a kite, right? I'm going to draw myself. Oh, you can see I'm not a very good drawer, but I've got my kite here, and okay, let's draw a little kite. Wow, that's actually shocking. I hope you can forgive the bad drawing, but and we're going to label all of our important bits. So we have that the string of the kite is 100 meters long. So we can write that this string is 100 meters. And the angle of inclination, so the angle that the string makes with the ground is 60 degrees. So let's actually say that I'll actually get rid of me here. And I'm just going to draw the ground. Say I'm at a park and I've just left this on the ground for a minute, and I'm holding my kite down with some weight here. So that's getting held. Okay, and the angle this is making with the ground, so the angle of inclination, we see this string is inclining, and that makes a resulting angle with the ground of 60 degrees. Okay. And we want to find the height of the kite. So we want this thing here. We want to see how far the kite is from the ground. So I've drawn this kind of imaginary line which goes from the top of the kite and hits the ground. Now, what's interesting here is that, well, let's think, what shape does this resemble? Between my kite, my ground, and my little imaginary line, I have made a triangle. More specifically, a right angle triangle, because looking straight from something in the air down to the ground, this makes a perpendicular. I mean, this makes our kite in relation to the ground. It has this perpendicular relationship. These two things meet at 90 degrees. So we are left with, in essence, a right angled triangle. Obviously, it's not real, but we can use this construct to solve real world problems. Now, I'm looking for a height h. So, now this looks kind of like any regular trigonometric ratio problem here. I can say that, well, what's my angle in question here? It's this one. And I can now classify my other sides in relation to this angle. So my 100 meters here, my string of the kite, and there is no slack in the string. So this is kind of like, what this essentially means is that it's just pretty much kind of held in place completely straight. Now this is opposite to my right angle. So this side is going to become my hypotenuse. Now, in relation to this angle of inclination, this one here, my height that I'm looking for is opposite this angle. So I can write my height is my opposite side. Now, if we write our trig ratios up here, we have SOHCAHTOA. We need a ratio that relates my opposite to my hypotenuse. And the only one we can choose as a result is this one. So I'm going to be using my sine. So we can say that the sine in relation to my angle 60 degrees equals to my opposite, this being h, over my hypotenuse, 100. Now we have an equation laid out that we can use like we did in the previous video. So we want to isolate our h. So we know that some number h, which when divided by 100, gives us sine 60. Therefore, we can represent our height as a product of 100 and sine 60 degrees. Now, you can plug this into your calculator. I'm going to plug it into mine now. And we will be getting an answer of approximately, let's do it to one decimal place. We have 86.6 meters. And let's do a little sense check as well. Well, I know my hypotenuse is the longest side. It always will be. And the answer I got is less than that, which makes sense because my other two sides, we'd expect them to be shorter. So it passes the sense check. Our answer, if we had something that was greater than 100, we'd be in trouble, right? Because we can use our logic to say, well, the hypotenuse is the longest side. So any answer I get, which I could have gotten from inputting maybe a wrong number in my calculator or doing something there, any answer greater than my hypotenuse for an opposite side length would be wrong. We would know that something has gone wrong. But the logic checks out in the answer we got. So recapping once again what we did, we just found all our keywords from the question, and we drew a diagram, and we can construct these right angle triangles in a lot of different scenarios. And you'll see this in a lot of your worded questions, maybe from your textbook. But I wanted to pick one that is relatively challenging with a little bit to deconstruct, and then applying the two concepts we learned in the previous two videos. Now, this is classifying classifying the sides of our right angled triangle in relation to the angle. That's what we did here. And then setting up our equation using the trig ratios we know. So I hope that made sense to all of you, and I'll catch you guys in the next video.